So to find the domain, the idea is you want to put a real x value in. You want to go through your function operation, whatever it might involve, and you want to get out an output that is also real. So the domain is going to be defined the set of all real numbers for which the output is real. So the question is, what could potentially cause a not real output? And there are two things that could potentially cause that. The first thing is if I have a 0 in the denominator, that is a no. That gives us an undefined expression. So the first issue is going to be if I have a denominator equal to 0, that would give us an undefined, which would not be real. So the domain is going to be all real numbers except for where this denominator is not equal to 0. Now, the second thing that could potentially give us not a real number is if we have an imaginary number. Now, what causes an imaginary number? That is caused by a negative underneath the radical. So what we want to ensure is that a negative is not underneath that radical. So in summary here, we're trying to put a real number in, get a real number out. But the things that are not going to be real are if we have a denominator that's equal to 0, or if we have a negative underneath, very specifically, the square root. Those are the two issues. So we want to avoid those two issues. So to avoid them, we are going to make sure that the denominator cannot be equal to 0, and we're going to make sure that whatever is inside of that radical is greater than or equal to 0. So in summary here, we will say that the domain is going to be all reals, so negative infinity to infinity, such that the denominator is not equal to 0, and whatever is inside that radical is greater than or equal to 0. So if you look at the worksheet here and you're trying to find the domain of a particular function, in this case we're trying to find the domain of x cubed plus 2 over 2x minus 1. Now, honestly, nobody could really care less about what the numerator is because the numerator can be equal to 0. But for our domain, we want to make sure that this denominator is not equal to 0. So we'll set 2x minus 1 equal to 0, solve, and get x is equal to 1/2. Now, we want to ensure that that number does not happen, because if that number happens, then we have a 0 in the denominator. So we would say that it's not equal to x is equal to 1/2, and that our domain is going to be all x's such that x is not equal to 1/2. Now, if you compare that to what is given in part B, in part B you have g of x is equal to x minus 2 to the 1/5. Now, you might remember this from intermediate algebra, college algebra, but this 1/5 is the same thing as the 5th root of x minus 2 to the 1st power. Now, what we're trying to avoid is a denominator not equal to 0 and a radicand greater than or equal to 0. But I didn't make a real big deal about this, but it's specifically an even radicand that has to be greater than or equal to 0. Because if you remember back in your intermediate college algebra classes, if you have a negative raised to an odd power or an odd root, that is perfectly fine. So you can have, for example, like the cube root of -5, and you will get negative cube root of 5. So this is perfectly fine. The fact that I have the 5th root of x minus 2 is fine. And so this, because it is odd, we would say that our domain is all reals, negative infinity to infinity. Now, if you compare that to part C, in part C you have h of x is equal to the square root of 2x plus 5. Now, in this case, we have an even root, we have a square root. And so because this is an even root, we have to ensure that this 2x plus 5 is greater than or equal to 0, because we do not want a negative inside of that radical. So we solve, we get x greater than or equal to -5/2, and that is going to be our domain, that x has to be greater than or equal to -5/2. Okay, so at this point it just seems like a review from pre-calc and college algebra and those sorts of classes, but this idea of a domain is going to be very important when we define the concept of continuity of a function, and that's a calculus concept. So for now, just remember please that the domain is going to be all real numbers except the denominator cannot be equal to 0, and if in radical, that has to be greater than or equal to 0, the radicand.